Now we'll discuss about stimulated emission. Now, in the earlier part, in spontaneous emission and stimulated absorption, we have seen that the rate of the spontaneous transition is determined only by the population at the higher energy level, whereas in case of absorption transition, it is determined by the population at the lower energy level as well as the energy density of the incident light. Now, if the absorption as well as the spontaneous emission were the only process which were there, then obviously the number of atoms absorbing radiation per second would be more than the number of atoms emitting light per second. So eventually what we'll see, we may end up in a condition where all the atoms are excited and they are all in the excited state. But this condition does not observe is in reality. What we see, the equilibrium condition is maintained. So in order to account for the state of equilibrium between light and matter, Einstein said that he pointed out that if a photon can stimulate an atom to move from a lower energy level to a higher energy level by means of stimulated absorption, then obviously a photon should also be able to stimulate an atom from the upper energy level or higher energy level to a lower energy level. So this method where the photon emission depends on the photon density present in the medium is known as the stimulated emission. So this is stimulated emission. So what happens in stimulated emission? You see the atoms which are present in the excited state, they do not have to wait for the spontaneous emission to occur. So what will happen before the spontaneous transition? An atom will make will interact with the photon present in the system, and that will make a downward transition. So these incident photon, they are interacting with the excited atoms and they are stimulating it or inducing it, and thus it is making a transition to the lower energy level. So this passing photon or the incident photon, they do not disappear. So in addition to it, there is a second photon which is emitted by the excited atom. Now the emission consists of two photons. Initially in the spontaneous emission, we have one photon, and now in case of stimulated transition, we have two photons which are emitted. So we have the inducing photon and we have the emitted photon, and these two photons, they have the same frequency, same direction, same phase and same polarization as the same polarization. So what is stimulated emission then? When an atom in the excited state jumps to a lower energy state under the influence of a photon, it emits an additional photon of the same frequency, same phase and same polarization as the incident photon. This transition is known as the stimulated transition or stimulated emission. Now, what is the probability of this stimulated emission? The probability of occurring this stimulated emission depends on the two things. Number one, it depends on the number of atoms present in the excited state, and number two, it depends on the intensity or the energy density of the incident light. Okay. Now, what are let us summarize the salient features of the stimulated emission. So the main characteristics of the stimulated emission is that stimulated emission is controllable from outside. And as I have already mentioned, the induced photon has similar features like that of the inducing photon. It has the same direction, same frequency, same phase and same plane of polarization as that of the stimulating photon. And one of the main or the outstanding feature of this process is the multiplication of the photons. I have drawn a picture here to make you understand. Suppose you have one photon which interact with the excited atom. Now what will happen? Now there will be two photons emerging out of the stimulated emission. Now these two photons traveling in the same direction, they will interact with two more excited atoms. And what will they do? They will generate two more photons and produce a total of 4 photons. Now these 4 photons in turn stimulate 4 excited atoms and generate 8 photons, and so on. So in this way the number of photons will build up and it will increase. And what will happen? So this is light amplification. So all the light waves that are generated in the medium due to one initial wave, and it will be seen that all the waves are in phase. That means all the waves are coherent and they will interfere constructively. I hope you have understood what is stimulated emission, spontaneous emission, and stimulated absorption. So if you like the video, you please subscribe and hit the like button.